Okay, so here's an example problem for LO1 in chapter 15. So we have a spring suspended vertically. There was a question in class. What happens if you suspend a spring vertically and the only thing that changes is where the equilibrium location is? So, for instance, here, if I just hang the spring, this is kind of where its equilibrium position is. But what we want to do is we're going to attach a mass to it. It's going to stretch a little because of the mass. In this case, it's 25 grams. And now we're told that it stretches 12 centimeters. If we look at forces, the restoring force acting on the mass is Kx acting up, and there's a force of gravity acting down. So Kx is equal to mg, but this becomes the new equilibrium location. This becomes the new x equals 0, but we're using this information about how much it stretched when I added the mass to figure out the spring constant. So K is mg over x. So it's 0.025 times 9.8, and then stretched 12 centimeters. This gives me a spring constant of 2.04 newtons per meter. And this is what I'm going to use from now on. This is the spring constant. We're going to take off the 25 gram mass and replace it with a 75 gram mass. And we want to know what the period of oscillation will be. I'm going to do this. I know omega is square root of k over m, and that's equal to 2 pi over period. So I can use this to find period. It's going to be 2 pi square root of m over k. So period is equal to 2 pi square root. My new mass is 0.075. My k is 2.04. If I do my calculation, I get 1.2 seconds as my period. In part C, they ask how many oscillations will there be every second. They're basically just asking me for frequency here, because frequency is the number of oscillations per second. Frequency is just 1 over the period. That's pretty easy to calculate. I get 0.83. So it's 0.83 oscillations per second. And finally, D, if the amplitude of oscillation is 15 centimeters, what is the maximum velocity that the mass has? V max is equal to omega A. That comes from the expression that V, when we take the derivative of the position with respect to time, we get minus omega A sine of kx plus phi. And this becomes the amplitude of the velocity, which is just the maximum velocity. That's why it's omega times A. Omega is a square root of k over m. I never calculated it, times A. Our amplitude is 15 centimeters, and I get a speed of 0.782 meters per second. Not too bad.